Okay, hello, I'm Fabio Pfeiffer, and these people listed here in the slide are the people who work in our group in the Instituto de Astrofísica de La Plata in Argentina. Okay, this talk is about massive early type galaxies. That galaxies is located in the left hand of this diagram, and here I list just some few of the most basic property of these galaxies in contraposition with the late type galaxies which locate on this side. So this figure show in a very schematic way the difference between the stellar population of this kind of galaxies. Early time galaxies form their stars very quickly and early in time. Okay, since the work of Tumre in 1972, we know that the interactions and the fusion between galaxies can transform the morphology of this object. However, we know that the idealized view of most of the massive early type galaxies forming by the binary merger of these galaxies is not always correct. This is a more realistic view of the process of ensemble of this kind of galaxies, where the stars in the movie are the minor mergers. So since the work of Osser, we think that the massive early type galaxy form in a process of two phases. The first phase is an in situ phase, which consists of an early collapse of gas and a giant burst of stellar formation. After that, we have another phase, the accretion phase, which consists of the later accretion of material that build up the stellar and dark matter halo. We think that the globular cluster systems of this galaxy form in the same way. In the first phase, the red globular clusters, the metal-rich globular clusters are formed, and some blue or metal-poor globular cluster too. And in the second phase, most of the blue globular clusters are accreted along with the low mass satellites. Okay, we started the program to study several examples of early type galaxies in the nearby universe, which show strong evidence of fusions of interaction. I will tell you about these three objects. The first example is NGC 4382, which is a galaxy, an early type galaxies in the outskirts of the Virgo clusters. It is the distance of around 18 megaparsecs, and it shows several structures that show that this object is a merger remnant. Okay, regarding the globular clusters of this galaxy, there are several previous studies. For example, Peng et al. Proposed that this galaxy is a good example of a possible three-modal color distribution. Color distribution. Che Santos proposed that this object have blue young clusters, and more recently, Trancho obtained near photometry for a small sample in the center of this galaxy, and they estimate an age is about 1.8 gigayears. And finally, Co obtained a GMOS mass for a small sample in this galaxy, and they found a group of globular clusters with ages between 2 to 4 gigayears. And they estimate a total population of 1,200 globular clusters, which mean a specific frequency of around 1.4, which is very low for a massive elliptical galaxy. You can see here the color distribution of this galaxy in black, and I will plot the color distribution for other two early type galaxies from Virgo, and you can see that the color distribution are really different. In this case, we don't see the typical bimodality, and it's clear here the presence of intermediate color globular clusters. In order to check if this is a correct interpretation, we run the two-dimensional Gaussian mixture modeling of Nedin, and we obtain that this globular cluster system is composed by 4 subpopulations: the classic blue globular cluster, the classic red globular clusters, an intermediate color group of globular clusters, and another group, the red object that we usually found in S0 galaxy. The name of that cluster is find fuzzy clusters. Okay, we obtain one GMOS mask for this galaxy, and we add the sample of course. So we have now 47 globular clusters in this galaxy, and we use the ULI scope to obtain age and metallicity for these globular clusters, and we can see which could be the old red globular clusters here and the old blue globular cluster here, and a lot of young globular cluster here. And it's interesting to note that the youngest globular cluster are the most metal-rich one. This is another plot. When I show you the alpha to iron values, we can see that the young globular cluster here show values from suprasolar to solar. So that means that the globular cluster were formed from progressively enriched material. Okay, we study a long slit spectra of this galaxy, and you can see here the presence of the kinematically decoupled core of the galaxy, and here the stellar population parameter, or the center of the galaxy, is a region with which is metal rich, and the center of the galaxy is dominated for a young stellar population. We recently started to study the same spectra with other technique, the PPXF. PPXF is nice because allow us to obtain the star formation history of the galaxy, and you can see here that the galaxy formed a star early in time, like most early type galaxy, but then this galaxy formed a star during the last 4 gigayears. Okay, if you want to see more details about this work, please see the Victoria Reinaldi's poster. Okay, the other galaxy is NGC 7000. It's a galaxy in a loose group which contains 4 galaxies. It is at the distance of around 50 megaparsec, and it shows several scenes of violent past. You can see that in the outer isophoto of this galaxy. Okay, this galaxy have a kinematical decoupled core too. You can see the presence of this here, and here is the result by Kleinenberg, where they present the result about the stellar population in the central part of the galaxy, and they found that the nucleus of this galaxy is young. Okay, regarding the globular clusters in this galaxy, Brown et al. Studied this system. They found a bimodal color distribution here, and they say that the low surface brightness in this galaxy are symmetrical, and then this galaxy is a result of binary merger. So if that is true, then they say that the blue globular cluster should be very metal poor and older, but the red globular cluster should be young and very metal rich. Okay, we obtain a deep field with GMOS in this galaxy, and a comparison field. We did the photometry. We select the globular clusters. Here I show you the result. This is the color magnitude for the science field, and the comparison field. You can see that we detect clearly the presence of the globular clusters in the galaxy. Here is the color diagram. And we analyze the luminosity function of the globular cluster, the black line. We fit the Gaussian function, and we obtain the turnover magnitude. With that, we obtain the distance of the galaxy, 50 megaparsec, which is a nice agreement with the previously reported value of Jensen. With this information, we can estimate the total population of the globular clusters in this galaxy. The number is 600. It's a very low number for a massive early type galaxy. Then the specific frequency for this galaxy is really low, 0.3. What about the color distribution of the globular clusters in this galaxy? Okay, we are seeing one of the histogram here, and it looks very strange. However, the things becomes clear when we consider just the brightest object. In black, we have plotted here the histogram of object which luminosity for object brighter than minus 8.5. And you can see there the system is clearly bimodal. The classic blue are here and the classic red are here. And when compared with the previous histogram, we can see that it seems possible that exists here another peak. So this galaxy seems to have two blue peaks in the globular cluster color distribution. In order to check that, we run the two-dimensional GMM, and we obtain that this galaxy, this globular cluster system, is composed of four populations. The blue globular cluster, the red globular clusters, the red globular cluster, the same that in the previous galaxy, fine fancy cluster, and the bluest object are here. So we put this the position of these peaks in this plot. This plot shows the position of the peaks of the globular cluster color distribution for galaxies in Virgo. It's a work of pen. So when we put the blue globular cluster, the blue globular cluster is in perfect agreement with the relation for the Virgo cluster, but the red globular cluster looks somewhat blue. And if we put here the bluest peak here is an outsider. One interpretation of this is that we are seeing the globular cluster system of lower mass galaxies. Another interpretation is just very simple, is that these objects are younger. Okay, we subtracted the light of the galaxies in our GMOS image, and we studied the low surface brightness structure. We detect these shells and some other structure like stellar stream, and we know that this structure here looks like an object being destroyed. So we use the unsharpening mask technique, and we know that this object is the same, and in the center of this possible object, there is an marginal resolved object with properties according to the nucleus of the early type galaxy. So we think that we are seeing here the process of destruction of a low mass galaxy in the halo of 1700. Okay, what about the stellar population of this galaxy? I mentioned the Kleinsberg value previously, but Francois et al. Has studied several massive early type galaxies using X-shooter spectra, and they obtain for this galaxy these values: young population and very metal rich. But we know that these values are in disagreement with the previous one. Another interesting thing is that these two studies use a comparison between Lick's index with a single stellar population. We obtain the spectra, the X-shooter spectra, and we use the PPXF. So we obtain this result where the galaxy is very old and metal rich, like another early type galaxy. So our result is in contradiction with the previous values. Okay, the last galaxy is this 5018, is another galaxy in a loose group of 5 galaxies at a distance of around 30 megaparsecs. We have in the stellar population in this galaxy, several authors found that the presence of young stellar population in the center of the galaxy and nearly solar metallicity. And they reported weak magnesium-2 index. So that is very strange for a massive early type galaxy. Regarding the globular clusters, the previous study is the Hilke and Kissler-Patrick, who found a poor globular cluster system, and they estimate this number of the total population. And they suggest that the globular clusters in these galaxies are very young. We obtain a GMOS field on this galaxy and a comparison one. The comparison field is here, the science field is here, and you can see that we detect the globular cluster systems of this galaxy, and it looks very, very poor. We have just 150 globular cluster candidates in this galaxy, and we know that the previous study of these globular clusters was strongly affected by the contamination, and probably that the photometry was not deep enough to study this galaxy. Okay, the color distribution of the globular clusters show that we have the clear peak of the blue globular cluster, but we not detect the red globular cluster. So these galaxies look very deficient in globular cluster, but especially deficient in red globular clusters. The numbers are low. We cannot say nothing more for the moment. We try to analyze the globular cluster luminosity function. Obviously, here there is no Gaussian, so we can obtain the turnover. But if we assume that this galaxy is located at 30 megaparsec, and if there are some classic globular clusters there, we can estimate a number of possible classical globular clusters. The number is 300. That is very, very low for a massive galaxy. So the specific frequency is 0.5. Okay, last question is, you know that most of the massive early type galaxies have hot halos detected in X-ray. So these galaxies have hot halos. We analyze the Chandra data, and this is the plot for NGC 7000, and you can see that in the spectrum we obtain the component of the hot halo, yes, and the parameter for the best fit. The other galaxy 5018 is the same. We detect the hot halo here. So the 3 galaxies are detected in X-ray. The dimmer is the first one, 4382, but all have some hot halo. And interestingly, Smith et al. Recently found that these 2 galaxies have this value very low, very high, sorry, and is typical for red and dead galaxies. So these galaxies seem to red and dead in this aspect. Okay, this is a summary of our result. Is the most important are the 2 last one, and I discover now that there is problem with the grammatical here, sorry, but the conclusion is it is possible that some of the progenitor of NGC 7000 and NGC 4382 were formed in the 2-phase process, but it's not possible that the 5018 was formed through the 2-phase process. Thank you.
Thank you, Fado. Just in time. Do we have any questions? The audience, yes.
Hello, Brian Miller from Germany. Very nice talk. Have you seen any differences in the kinematics between the different globular cluster populations?
We have a spectra just for the first galaxy, and yes, there is a difference. Is for another talk, and I'm sorry, I forgot to say that the result about these galaxies was published recently. So yes, and
Great, great talk. Could you go back one slide, I think? Yeah, this will do. So looking at these plots and similar plots that you've shown, you have really good fits for, 2 keV and less. What's going on after that?
you say you talk about that.
Yeah, because I mean, like,
Yes, for me, it's not important. I just want to take off that component. But Victoria, she's our specialist. For globular cluster, it's just important the first. Right.
Never mind. Next ray. That galaxy is very faint in harder X-ray. If you decompose the emission in the softer band and in the harder band, you will see that the most of the emission comes from the soft band. So the broadband spectra shows that this is a very noisy. I forgot the word. And the hard X-ray band has very poor signal to noise, very few photons detected, and you will see the error bars are huge. So the problem there is it's just faint.
Do you have any more questions from the audience?
We have in Slack.
Hello, I'm Song from University. Very nice talk. I just wonder, you assume that very blue and very red globular cluster are very young. I understand the blue is very young, but do you think that for the red one there's
No
extinction or?
No, I talk about the red and the very blue. This one and this one, because if the globular cluster are younger, they are bluer.
You mean?
And the same here.
Yeah.
But we can't say anything because we have the age and metallicity degeneration. We need some spectra to know what is happening here, or very good near infrared data.
So how about the very red one? So you.
And the very red ones are this one.
Yes.
In several. Sorry.
Yeah, I mean do you have any opinion of what is very red one?
Yes, that cluster are usually found here. Yes, and was studied in some near S0 galaxies, and they are faint cluster, much more like to open clusters, not exactly globular clusters.
Okay, thank you.
And we have one last question from Slack, I guess.
Yeah. So Joel Rediger is asking, have you looked at cosmological simulations to see how common are galaxies like the ones you have observed?
Okay, this is the next steps. No.
Okay.
Okay.
So let's thank Fabio again. Thank you.